panel's notation regarding garage door and light circuits sharing a neutral and requiring placement on separate legs addresses potential issues related to voltage drop, inductance, and electrical code compliance. When a substantial load, such as a garage door motor, draws a significant current, it can induce a noticeable voltage drop along the neutral conductor. This voltage drop effectively diminishes the voltage available to other devices sharing the same neutral, notably lighting circuits. Should the lights and the garage door motor utilize the same neutral connection, the voltage drop caused by the motor can lead to dimming or flickering of the lights. This occurs because the decreased voltage is insufficient for proper operation of the lights. The National Electrical Code, or NEC, mandates that circuits with significant inductive loads, such as garage door motors, be situated on independent circuits or across different phases of a multi-phase system. This is to mitigate excessive voltage drop on the neutral conductor. When multiple inductive loads utilize a shared neutral conductor, the respective magnetic fields can interact. This interaction generates an inductive pathway between the circuits, resulting in parallel inductance. This parallel inductance can elevate the impedance of the neutral conductor, further diminishing the voltage supplied to the loads. By situating the garage door and light circuits on separate legs of the panel, the inductive loads are effectively isolated, averting the development of parallel inductance and minimizing voltage drop along the neutral conductor. This measure ensures that both circuits receive adequate voltage for proper operation. The separation of the garage door and light circuits on different legs of the panel is a design practice intended to ensure that both circuits receive sufficient voltage to function correctly. This setup mitigates voltage drop concerns that could otherwise lead to dimmed lights or other electrical malfunctions. The voltage drop issue arises due to the nature of electrical circuits and the behavior of current flow. When a device draws current, it creates a voltage drop across the wires and components in the circuit. This voltage drop is proportional to the current and the resistance of the circuit. In a shared neutral situation, the current from both the garage door and the lights flows through the same neutral wire. When the garage door motor is operating, it draws a large amount of current, causing a significant voltage drop on the neutral wire. This voltage drop reduces the voltage available to the lights, causing them to dim. The NEC addresses this issue by requiring that circuits with large inductive loads be placed on separate circuits of different phases. This helps to distribute the current load more evenly, reducing the voltage drop on the neutral wire. The concept of inductance also plays a role in this issue. Inductance is a property of electrical circuits that opposes changes in current flow. When the current in a circuit changes, the inductance creates a back voltage that resists the change. In a shared neutral situation, the magnetic fields generated by the garage door motor and the lights can interact, creating an inductive path between the two circuits. This parallel inductance increases the impedance of the neutral conductor, further reducing the voltage available to the loads. Separating the circuits on different legs of the panel helps to isolate the inductive loads and prevent the creation of parallel inductance. This ensures that each circuit receives the proper voltage. In addition to voltage drop and inductance, there are other factors that can affect the performance of electrical circuits. These include the wire gauge, the length of the circuit, and the type of load. It is important to consider all of these factors when designing and installing electrical circuits to ensure that they are safe and reliable. Firstly, voltage drop is a critical factor to consider. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a conductor. This drop is due to the resistance of the conductor. The longer the conductor, or the higher the current flowing through it, the greater the voltage drop. In the context of a shared neutral circuit, a significant load, such as a garage door opener, can draw a substantial amount of current. This high current can cause a considerable voltage drop on the neutral conductor. This reduced voltage can then affect the performance of other devices sharing the same neutral, particularly lights. Insufficient voltage for lights can manifest as dimming or flickering, which can be both inconvenient and potentially damaging to the lights themselves. Secondly, inductance plays a key role. Inductance is the property of an electrical circuit that opposes changes in current. This opposition arises from the magnetic field created by the current flowing through the circuit. When two inductive loads share a neutral conductor, their magnetic fields can interact. This interaction can create an inductive path between the two circuits, resulting in parallel inductance. Parallel inductance increases the impedance of the neutral conductor, further reducing the voltage available to the loads. Placing the garage door and light circuits on different legs of the panel effectively isolates these inductive loads, preventing the creation of parallel inductance and minimizing voltage drop. Thirdly, electrical code requirements are crucial. The National Electrical Code, or NEC, sets standards for electrical installations to ensure safety and proper functioning of electrical systems. The NEC addresses the issue of shared neutrals and large inductive loads by requiring that these types of circuits be placed on separate circuits or different phases of a multi-phase system. This requirement is intended to prevent excessive voltage drop on the neutral conductor and to minimize the risk of electrical problems. Compliance with the NEC is essential to ensure the safety and reliability of electrical systems. Fourthly, the implications of shared neutral circuits are diverse. While sharing a neutral might seem like a way to save on wiring, it can lead to a range of problems. In addition to voltage drop and flickering lights, shared neutral circuits can also cause overheating of the neutral conductor, which can be a fire hazard. Furthermore, if the neutral connection is lost or becomes loose, the voltage on the circuits can become unbalanced, potentially damaging appliances and equipment. Fifthly, consider practical solutions. The best way to avoid the problems associated with shared neutral circuits is to run separate neutral conductors for each circuit. This ensures that each circuit has its own dedicated return path for current, minimizing voltage drop and preventing the interaction of magnetic fields. In cases where it is not possible to run separate neutral conductors, it is important to ensure that the neutral conductor is properly sized to handle the combined current load of all the circuits sharing the neutral. Sixthly, maintenance and inspection is critical. Regular inspection and maintenance of electrical systems can help to identify potential problems before they become serious. This includes checking for loose connections, damaged wiring, and signs of overheating. It is also important to ensure that all electrical work is performed by qualified electricians who are familiar with the NEC and other applicable codes. Seventhly, understand the different legs. In a typical 120V/240V split-phase electrical system, the panel has two hot legs, each carrying 120V with respect to neutral. The voltage between the two hot legs is 240V. By placing the garage door circuit on one leg and the light circuit on the other leg, the loads are balanced across the two legs, reducing the overall current flow in the neutral conductor. This helps to minimize voltage drop and prevent overheating. Eighthly, consider troubleshooting. If you are experiencing problems with dimming lights or other electrical issues, it is important to troubleshoot the circuit to identify the cause of the problem. This may involve checking the voltage at various points in the circuit, measuring the current flow, and inspecting the wiring for damage. It is also important to ensure that the neutral connection is secure and properly sized. Ninthly, refer to the National Electrical Code. The NEC provides detailed requirements for electrical installations, including requirements for shared neutral circuits and large inductive loads. It is important to consult the NEC when designing and installing electrical circuits to ensure that they comply with all applicable codes and standards. The NEC Article 210.4 addresses multi-wire branch circuits, which are circuits that share a neutral conductor. This article specifies the conditions under which multi-wire branch circuits are permitted and provides requirements for overcurrent protection and other safety measures. The NEC Article 210.23 specifies the permissible loads for branch circuits. This article limits the amount of load that can be connected to a single branch circuit to prevent overloading and overheating. The NEC Article 250 addresses grounding and bonding requirements. This article specifies the requirements for grounding electrical systems to provide a safe path for fault current and to minimize the risk of electric shock. Tenthly, ensure professional consultation. If you are unsure about any aspect of electrical wiring or circuit design, it is always best to consult with a qualified electrician. An electrician can assess your specific situation, identify any potential problems, and recommend the best course of action. They can also ensure that all electrical work is performed safely and in compliance with all applicable codes and standards. Separating the garage door and light circuits on different legs of the panel is a safety measure to prevent voltage drop issues.